Good morning, students. It's Mr. E. Today we're going to start this new unit, solving systems of equations. Now, a system of equations is where we have two variables that we want to solve for. And we'll get to that in just a second, but first I want you to take a look at this graph. Here I've got two lines. One is y equals minus 2x, and that's the red line here. As you can see, it doesn't have a b value. The b value is plus 0, so it goes through the origin here. So there's our slope-intercept form. And then here's another one. This one is y equals x plus 3. That's this blue line here. As you can see, this one has a negative slope, so it's going down. This one has a positive slope, so it's going up. And we have been graphing a little bit last unit. We graphed some parallel and perpendicular lines, and we saw, that the perpendicular lines, of course, cross. And so first I want you to just remember what these lines are. And we can help by just doing this. We can turn each of these equations into a table to remind us that these equations is just like a little framework for these numbers. And these numbers, each row, of course, is a dot here, a point on the line, the whole numbers. And that's what these tables are. Each one of these is just each one of these is just a point on these lines. So notice this point right here is shared by both lines. Minus 1, 2 is shared by both lines. So let's keep that in mind as we go to our unit packet. Here it is. Let me get this up right, and we'll dive right in. So, solving systems of equations. What does that mean? Well, here's our two equations. We had y equals minus 2x and y equals x plus 3. Let's put this point in for x and y and see what happens. So I'm going to use 0 for x and 4 for y. So I'm going to rewrite this one first. 4 equals minus 2 times 0. Well, minus 2 times 0 is 0, so 4 equals 0. That doesn't work. Let's see what happens with the other one. 4 equals 0. That's the x plus 3. Well, that's 4 equals 3. That doesn't work. So this point is not on this line. Because none of these things work here, that point 0, 4 is not on that line. And we can go back to our graphing calculator. Is 0, 4 on that line? No, it's not. It's not here, it's not there, it's not any of these. 0, 4 would be 1, 2, 3. Would be up here someplace. Do I have a mouse? Anyway, it would be just there above the blue line on the y-axis. So that's not what I want. So that didn't work. So let's see if this point, minus 1, 2, and you might have noticed that one was in one of the tables. Let's see what happens when we plug that in. So here's my x and here's my y. So 2 equals minus 2 times x, which is minus 1. Minus 2 times minus 1, that gives me positive 2. So that works. Okay. How about this one? 2 equals x, which is minus 1 plus 3. Well, minus 1 plus a 3 is 2. So that works as well. So because that point, this point right here, minus 1, 2, is on both tables. Minus 1, 2 is the second point here. That one right there. And minus 1, 2 is the second point here on this line. That's, okay. That is the point where they cross right there. Right there in the middle. I can't circle it because I can't draw on that screen, but that's where they cross, right there. So it's a solution to both lines. And that's what we're going to be doing all this unit. We're going to find the place where those two lines cross, the solution for both. So let's take some notes here. If a point works in both equations of a linear system, and that's what we call this. If you have two equations or more, we call it a system of equations, and they both share these variables. The x in this equation is the same as the x in this equation. That's the only way this works. The y in this equation is the same y in that equation. So that's the only way this all works. If they were different, then we'd use different letters. So they're all the same. Anyway, if a point works in both equations of a linear system, then that point must be the solution to the linear system. So we're going to be looking for the solutions that satisfies both equations that we have. So when we solve systems of linear equations, you find that one solution that makes both equations true. Just like here and here. Here's that one solution that makes both equations true. So there's a few methods to solving systems of equations. We can use graphing, which is what we're going to explore today. We can use a method called substitution. We'll learn how to use that. And then we have a method that we call elimination, which you will be using probably most of all, especially in geometry and algebra 2. You'll be using that most of all because it's probably the easiest. So these solutions, what do they look like? Well, we can have either one solution, and that's basically what you probably think it is. If I have two lines on a graph, the solution is where they cross. So two lines cross at a point. That's what one solution looks like. It's right there. It's where the two lines cross. And I know I drew it right there in the middle of a box, but all of these will be whole numbers. It'll be easy for you. It'll be whole numbers. Substitution. I'm sorry, not substitution. No solution. We can have no solution. And where do you think that might happen? That means that those lines never cross, which is something we just explored in the last unit, parallel lines. Parallel lines have no solution. Parallel lines. They never cross. So the equation of this line here, y equals something, I don't know, is not going to share a solution with this y equals something else. Okay? And then the last method, infinite solutions. We can have infinite solutions, and that just means that I have, do it this way, that I basically have one line. It's the same line. So there's one, they're on top of each other, basically. That's why I did that. So we have one solution. Infinite solutions means we have the same line, just the same line. So we might have two equations, but it turns out that they're both the same equation. They're just in different forms. Remember, we can have different forms of the same equation. Okay, so let's keep on going. Oh, well, actually, here, let me put some examples down. So an example of this first one, what the equations look like. Here's an example of equations. Example equations would be like the two that we just have, y equals minus 2x, and then y equals x plus 3. These are two different ones, and they met there. Parallel lines, well, they have the same slope, so maybe something like y equals 2x plus 4, and then y equals 2x plus, or this one is, the bottom one looks like it's a minus 2, something like that. So same slope, different b values, different y-intercepts. And then the last one right here, same line, so it would be like y equals, what is that, 1/2 x plus something like that. It would be the same. Okay, let's keep on going. Okay, we're going to solve by graphing. This is probably the easiest way because you could plug it into Desmos or on a calculator, and you could just see where the solution is. So that's pretty easy. All right, so we're going to put the equations for graphing. We're going to put them in slope-intercept form. Of course, that's y equals mx plus b. That's our favorite. That's the easiest. And then we're going to graph each equation in the same coordinate plane. So we're going to use one grid to graph both of these equations. And then we're going to locate the point of intersection. Point of intersection. And write it down. And you know what? Here's a symbol for intersection. We'll use that in geometry next year. Okay, so we're going to locate the point of intersection, write it down, and then we're going to verify that the point makes both equations true by just plugging it in and checking our answer. So let's graph this. Let's graph these two. These are the same ones that we had. I'm going to use purple for this. So this, remember, this was a plus 0. It looks like a minus 0. This is a plus 0. So that's what the b value is. It's at 0. So there's right there. And then I'm just going to count the slope. We go down 2 and over 1. So there's my next point. Down 2 and over 1. Down 2 and over 1. Here's my points. I can go up and backwards. There we go. Okay, so there's my purple line. Y equals minus 2x. And then I'm going to put this one in orange. Let's see. Y equals x plus 3. So this is my b value. So I'm going to go to 3. 1, 2, 3. And the slope is 1. So I'm just going to go up 1 and over 1. So here's where all of those are. It's an easy slope. There we go. There's the intersection right there. I'm going to circle that one so we can see it. Here's the orange line. And there's the point of intersection. That's at minus 1. We went back 1. So minus 1 up 2. Minus 1, 2. That's the point of intersection. So I'm going to mark that. Point of intersection. The solution, minus 1, 2. All right, let's verify our solution. We're going to plug this in for x and this in for y. So this is going to be 2, and this is going to be minus 1. So I'll rewrite this. 2 equals minus 2 times a minus 1. And you know what? We already verified this earlier. 2 equals 2. Check. 2, and this is going to be a minus 1. So 2 equals minus 1 plus 3. 2 equals 2. There we go. So our solution has been verified, and we've done it. Let's do a different one. Let's go over here. Let's do solve the system equation by graphing. All right, let's plot this one. Here's my b value. Begin with b. 1, 2, 3, 4 right there. And then move with m. My m is minus 1. So I'm going to go down 1 and over 1. So this is a negative slope. Go down like this. Okay, blue line. Whoa. Shaky here. A blue line. Let's use. I thought I had pink. That's close. Let's do this. All right, we're going to begin with b minus 8. 1, 2, 3, 4, 5, 6, 7, 8. And move with m. Is 2. So up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2. There we go. 2 and over 1, 2 and over 1, 2 and over 1. Okay. There we go. So there's our pinky red line. All right. What is the solution? Is this point right here, and that's 1, 2, 3, 4. So the intersection is at 4, 0. Here's my intersection, 4, 0. So where they cross is 4, 0. That's my x and that's my y. Let's plug these in and verify our solution. Let's see, x is 4. And y is 0. Okay, so we write this, y equals minus 4 plus 4. Yeah, that's right. 0 equals 0. Minus 4 plus 4 is 0. Okay, so y is 0. X is 4. So this is 0 equals 2 times 4 minus 8. 2 times 4 is 8. 8 minus 8 is 0, so that checks out. There's our solution. All right. Well, let's keep on going. Let's see what we have next. Here's a couple more. Solve this system of equations by graphing. Oh, what form are these? These are in standard form, so we can do something real easy. We can find the x and y intercepts to plot these. So the way we find the x-intercept is we set y equal to 0. So if that is 0, it just goes away, doesn't it? I'm just going to get rid of all of it. It's 0. So let's solve this. 2x minus 2 divided by 2, x equals 1. Okay, there's my x-intercept. X equals 1 right there. Write this down here. X equals 1. X-intercept. Now the y-intercept, I'm going to set x equal to 0. That means this whole thing goes to 0, so that goes away, and that just, well, that's easy to solve. Y equals 2, so here's 2. You know what? I'm going to rewrite these as points. So this is 1, 0, 0, 2. Alrighty. So there's 2 points, and look, they're real close. So it looks like my slope is 2, so, or minus 2, because I go down 1 and over 1. So slope is minus 2. And you know what? I realized on the front page it said we're going to put these into slope-intercept form. So let's do that. Let's just subtract 2x from both sides. So that means we have y equals minus 2x plus 2. And we could plot from this as well. Here's the y-intercept. Go down 2 and over 2. Or down 2 and over 1. So there we go. We'll do the next one that way. It doesn't matter either way. Whatever you're comfortable with. Let's put this one in. Okay. Oh, that's pretty easy. Let's set this in slope-intercept form. So we're going to subtract x from both sides. Minus y equals minus x plus 4. And then we just change the signs of everything. There we go. Y equals x minus 4. So I'm going to start at minus 4 on the y-axis. That's my b value, and my slope is a positive 1. So 1, 1, there's the intersection. Here's all my points. I can draw my line. There we go. And so the intersection is at 1, 2, 1, 2. 2 minus 2. That point right there. So the solution is 2 minus 2. And let's verify just to double check. I think we're pretty confident, but let's do that. So remember, this is x and this is y. We'll just plug it in the blue one first. So x is 2. Y is a minus 2. So in this equation, don't forget this sign right here. It's actually 2 minus a minus 2 equals 4. So that means this is actually 2 plus 2. And that is indeed 4. So that checks out. Let's go to our other one. So x is 2 there, and y is minus 2. So this is 2 times 2 plus a minus 2 equals 2. That's a lot of 2's. So this is 4, and a plus a minus 2 is actually minus 2. So 2 equals 2. Okay, let's do one more. Let's go over here and do this one. Let's agree this time. All right, solve the systems by graphing. Here we have another one like this. Let's convert. We need some practice converting. Let's convert that into slope-intercept form. So I'm going to add 4x to both sides. So that gives me 2y equals 4x plus 8. I'm just writing this in order there. And we're going to divide by 2. Everything divides by 2. So that's y equals, that becomes a 2x, and that becomes 4. So let's go and plot that. Here's my b value. 1, 2, 3, 4 right there. And then the slope is 2, so up 2 and over 1, up 2 and over 1, or down 2 and backwards 1. Down 2 and backwards 1. I can draw my green line. There we go. And let's use some of these. Oh, hey, look, this is already in slope-intercept form. Perfect. So let's go to minus 2. And then my slope here is minus 2. So down 2 and over 1, 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 up 2 and backwards 1, up 2 and back. Yeah, I can barely see that yellow line, but it's all right. There we go. There we go. Oh, goodness. Well, where do those cross? Those cross right there. Did I graph that correctly? Yes, I did. Looks like a half number, doesn't it? Did I ever graph that wrong? That's about right. The solution is probably, looks like it's a minus a 1/2. Minus 1.5 and up 1. Probably that. Minus 1.5. 1. Let's verify. Let's use a decimal. Let's see if that works. So here's my x, here's my y. X is 1.5. Y is 1. Oh, minus 1.5. There we go. So a minus 4 times a minus 1.5 plus 2 times a 1 equals 8. Okay. Minus 4 times minus 1.5, that is 6. Positive 6. Plus 2 times 1 is 2 equals 8. Hey, look at that. That works. All right, let's try this other one right here. Let's put in, so y is 1. X is minus 1.5. So 1 equals minus 2 times a minus 1.5 minus 2. It stays the same. A negative 2 times a negative 1.5, that is a positive 3. Minus 2. 1 equals 1. There we go. All right. Not so bad. Okay, let's see what the next page gives us. Oh, special cases. All right. Here's some special cases. All right. Let's solve the system of equations by graphing. Alrighty, here are 2 equations. Let's see what we got going on here. Let's plot this one. Let's convert. So we let's convert. Y equals minus 2x plus 1. Okay, so plus 1 is my y-intercept there, 0, 1. And my slope is a negative 2, so down 2 and over 1. Here's this line. All right, back. Here's this line. Okay. There's that. All right, what's the next one? Let's convert this too. So I'm going to add 6x to both sides, plus 6x. That gives me 3y equals 6x plus 3. Divide by 3, divide by 3, divide by 3. Y equals, well, that becomes 2x. That's 1. Okay. Y equals 2x plus 1. What happened here? Oh, you know what I did? Let's see what happened here. I added on this side of the red one, but I subtracted on this side. There's a mistake. Let's correct it. This should be plus 2x. So there's plus 2x right there. So looky what we have. Y equals 2x plus 1. And also, y equals 2x plus 1. These are the same line. So all of these are going to be right on top of all of those. So we have the same line. This is the same line. This means we have infinite solutions. Infinite solutions. Cool. Same line. So every point matches every point on the red line matches every point on the green line because they're the same equation. Okay. Well, there's one of the special cases. Let's look at this next one. Solve the system's equation by graphing. All right. Let's convert this. So let's subtract x minus 2y equals minus x minus 8. Let's divide by that coefficient. Go down. So y equals negative over negative is a positive. There we go. Here's our first equation. Let's plot that. Here's 4 on the y-axis. My slope is 1/2. Up 1 and over 2. Up 1 and over 2. Up 1 and over 2. And down 1 and back 2. There's a purple line. Let's do an orange line. X is already on that side. So let's move this over. Plus 6. 6 minus 2y equals minus x plus 6. Divide by the coefficient. So y equals, that's a positive 1/2. X again, that's a minus 3. Okay, so we have a different equation this time. But some of you might notice the similarities here. So my b value here is a minus 3. So 1, 2, 3, right there. Slope is 1 over 2, which, if you haven't noticed by now, it's the same slope as the purple line. So are these ever going to cross? No, these are never going to cross. These are parallel lines. Same slope, different b values right there. So these are never going to cross. So this has no solution. No solution. Parallel lines. All right, let's do a couple more. Some other special cases here. All right, let's convert this. Minus 2x on this side, minus 2x on that side. That goes away. Y equals minus 2x plus 2. Here's that b value at 2. And our slope is down 2 and over 1. Down 2. Up 2 and back 1. Here's a blue line. Here's the first one. All right, let's use... Okay, this for this one. All we have to do is subtract 2. So y equals minus 2x minus 2. Okay, let's see what happens here. Negative 2 is down here, and my slope is minus 2, which, looky here, it's the same slope again. So here we have another. Which one is this? No solutions? No solution? This is no solution. No solution. Parallel lines. Remember, parallel lines. Oops, parallel lines. Same slope. All right, let's do this last one, then we'll be done. Yeah, solve this system. Okay, let's subtract x from both sides. I got 2y equals minus x plus 4. Divide by the coefficient. Got y equals minus 1/2 x plus 2. Here's my first line. Plus 2 is right there. Up 1 and over 2. No, not up 1. Down 1 and over 2. There we go. Down 1 and over 2. Down 1 and over 2. We're up and backwards 2. Purple line. Alrighty, let's do screen. All we have to do is divide by 2 for this. So it gives me y equals a minus 1/2 plus 2. Well, what do we have here? We have another one with the same line. All of these points are the same. Start at 2. Same slope, same y-intercept, so it's the same line. So that means we have infinite solutions. All right. Well, I hope that wasn't too difficult. This is really the easiest version of solving systems of equations, in my opinion. So hope this helped, and I'll see you for the next one.